ritual for whenever it is that we're working on a question. So it says here, right? Sine x plus sine 2x, the whole thing over 1 plus cos x plus cos 2x is equal to 10x. So before we even start, right, I'm going to show you something that you always want to do before you attempt an identities question, especially one that maybe looks a bit weird. What you can always do before attempting an identities question is just double check if everything is like written out properly, or rather just double check if the expression is valid. What I mean is, if the expression is valid, it means that if you choose a random value for x, it should balance your equation. What that means is, let's just choose a random value for x. Let's even choose like a 10. So what you're going to do is, in your calculator, you're going to put 10 there, 10 here, 10 here, and 10 here, right? And then you're going to get an answer for the left-hand side. After doing that, you do the same for the right-hand side and also get an answer. And then you just need to double check if those answers will be equal to each other. So if you maybe missed what I mentioned now, I was just saying that to make your life easier, right? You can always just double check if your expression is valid by throwing in a random number for x on the left side, and then that same number, put it on the right, and then see if your equation balances. If your equation balances, it means that the expression you're trying to solve is okay. There's nothing weird about it. So let me just do that in the calculator. So I'm pressing the fraction button. I'm using 10 as the dummy value. So I'm putting 10 where x is, and then sine 2 times the 10 there. At the bottom, 1 plus cos with a 10 plus cos 2 with a 10 there, close bracket. So on the left, the number I'm getting in the calculator is the number 0.176, blah, blah, blah. So on the right, if we put sine 10, we should get the same answer. Sine 10, we're definitely getting the 0.176, blah, blah, blah. So what this means is you will be certain that, okay, whatever you're trying to prove here, there's no error. Like there's no issue with the question that you're given. It means you can comfortably work out what you need to work out without thinking that if you do get stuck, there's something wrong with the question. So to start off, right, normally, we all know you always need to work with the side that looks a bit more complicated, of which in this case, it's the left-hand side. So the left-hand side, I mean, one thing to, really take note of is how there's a double angle up here, and then down here, there's also like a double angle here. So the easy thing is, for sine's double angle, right, this one you can always change immediately. Like you really don't even need to think twice about it, because you can only change it into one thing. The one at the bottom, though, the one where you have cos 2x here, this double angle there, we know that according to your formula sheet, we know that this can be changed to one of three things. So if you're a bit skeptical of what to change it to, I mean, just looking at how we have a cos already here, you may think to yourself, let's change this to a cos as well. And that's my thinking also. But then if, let's say, you're still a bit skeptical, you can actually just leave this for now and then actually only change it later, after you know there's absolutely nothing you can do elsewhere. So at the top, it looks like we can fortunately take out a sine x as a common factor. So let's see here. If sine x goes out, we'll have 1 plus 2 cos x. So judging from what we have at the top, right, it looks like at the top, once we're factorized, we're going to have a bracket that looks like this and something else that looks like this. So for the bottom, I mean, like one or the other, we maybe want to also have something here where we can maybe also factorize the bottom, because it looks as though if we can factorize the bottom, we will have something at the top canceling out something at the bottom. And then, I mean, like we already know that for us to end up with 10x, we need to have sine x over cos x somewhere, you see. So on the left here, we need to end up with sine x at the top and then cos x at the bottom. So that would be one reason for us to change this to 2 cos squared x minus 1. So I put brackets there as a habit, because as long as you're changing this to something, always put brackets there. But fortunately, because there's a plus there, we know that nothing is going to be affected here. So let's just remove those. And then this cancels of that. And then what do we have? We have sine x at the top here, 1 plus 2 cos x. At the bottom, if you look nicely, you can take out a cos as a common factor. So that'll be cos x here, and then here it's like 1 plus. Here, if you take out a cos, it's gonna be 2 cos x left. And then would you look at that? I think this question was just masked in, you know, in whatever it was masked in. So I think one thing we can take away from this question is if you need to change the double angle of cos, right? You don't have to do it immediately. You can always just do it when you can refer to something to help you make your decision. So for this question, you can then eventually say, therefore, left-hand side is equal to right-hand side. Nothing crazy, nothing too major. So yeah, I think that's that for this question. So the theme with the group sessions is that obviously if someone has like specific questions that they need to ask, you can always just ask those. You can always just send them on the group, and then we can work on those. And then if there are no questions specifically, then we'll just be carrying on with the June paper 1 past paper, because what happened? What's that thing? I think last week we ended up with, where did we end up? Yeah, we ended up wherever we ended up. But I think let me just actually stop this recording and start a new one for our past paper. So let me stop